All right, hello everyone. As Phil said, I'm Phil Wills and I'm Senior Software Architect at TheGuardian. And my talk's a bit different in that I'm not talking about any particular technology in any depth today, but I'm going to go through our approach to scaling in general at TheGuardian. Just to give you some context into where we are as an organization. So hopefully most of you will be aware that we're a news organization. We publish lots of content every day, and I believe, certainly according to some measures, we're now the second most popular English-speaking newspaper website in the world these days. So yeah, we have a website, we have some apps, and in total we're doing a few hundred requests per second over those. We've got tens of different services we support. We've got about 50 or 60 developers, and we have hundreds of servers in production running all those different services. And as well as examples of other services we have apart from the website, we have some analytics tracking what people are doing on our site in near real time. We have our content API, which is what actually powers the website and the apps and gets the content to them, but is also available for other people to go and reuse our content. We have a commenting platform for people to come and generally abuse our writers on. And we also have a custom CMS in which our writers go and do their publishing. One thing which is quite unusual about me in the tech community is I've been at TheGuardian for a long time. So I started at TheGuardian back when the website looked like this. So this was back in 2002. And at that point, The Guardian was being run on something called Vignette Story Server. And the way that that worked was essentially it got its performance by writing out the rendered HTML to disk and then letting Apache serve that, so that once it had calculated it once, it didn't have to do the work again. And this worked pretty well as an approach, except when the new guy fresh out of university who's been there for a few months accidentally deletes half of those files off the disk. And consequently, the whole of the website is pretty much unavailable for the next 5 or 6 hours. That was not my favorite day in the job. But the reason why I bring that up is because these days, if I had made that kind of mistake, we shouldn't have had that kind of problem for that kind of extended time. Because even if we were still in a system, which we're not, where we had everything being written out to disk, if we had accidentally deleted the things, the problem was that the servers to regenerate it were just completely overloaded at that point, and there was nothing more that we could do. We were running on all the machines we had. This should not be something these days that is an issue. And, 12 years on, I still make some silly mistakes. But these days, when I make the silly mistakes, like accidentally putting 3 times the load that we had previously on our analytics tracking system, then I put 3 times the load on, well, I'll put 3 times the number of servers up. And I might only do that for a few hours, but the ability to do that, it gives you the headroom to actually think and analyze the problem and get to the root cause without panicking. Whereas back in 2002, I was definitely panicking and mainly just beating myself up rather than wondering about how I could stop this happening again in future. So moving on through time, that system was run when it was actually generating things, it was generating them in a language called TCL or Tickle. And on the features page of Wikipedia, this is listed as a feature. If that doesn't scare the hell out of you, I think you're probably doing the wrong job. Back in 2005 or so, we started on replacing this system with a completely new one. And back in 2005, what the relatively cool kids were doing was Spring and Hibernate. So we decided to jump on that train. We kind of started, in some ways, with the tooling to actually build and publish our website. So we went away and started building some tools to go and publish our content. And we used the sort of standard ORM patterns of building mappings from objects onto database tables and then loading them up and saving them back to the database. And it worked pretty well for the tools. And so we thought, great, we want to maximize reuse. We want to not repeat ourselves. We shall go and render the website using that same ORM model. That didn't work out terribly well. So to go off and render the front page like this took, I think it was last time we looked, it was somewhere around 1,800, maybe 2,000 database calls in order to render something like this. And that kind of melted our database quite a lot. So subsequently, we put in various layers of memcache and eventually got to the point where it performs fine. And it's been working fine for the past 7 years or so. But we gave, getting to that point where we were actually comfortable with it and happy with it, and it wasn't incredibly fragile, took a lot of time and effort. And fundamentally, we were doing a lot of work we didn't need to do. And the big takeaway I took from that was around separating the data representation for storing from how we query. So, this back in the mid-2000s, I was very keen to kind of normalize everything off and try and keep data in one place and one place only. Now I'm not quite at the opposite extreme, but in general, I'm very much on the kind of CQRS, command query, responsibility separation theme, where I view how you look at your data as being often very different in terms of how we want to write it from how we want to read it. And even if they're not separate, then you should at least be starting from the point where you're optimizing for the difficult case, which in our case was rendering the website for millions of people, as opposed to the easy case, which was storing some data for hundreds of people. So, having said all that, we had the system, it was working, but we did have another issue. So, we've got our network front, which is accessed by millions of people a day, but we also have some less visited pages, like, for instance, this one. And this is using some very different data. This isn't something which is written by any of our journalists. This is coming from a third-party supplier. And this ended up going into exactly the same system as the content which is rendered by most people. And building this kind of feature was really slow and painful because we had to support exactly the same performance characteristics as we did for the thing that was being read by everyone, because if not, we risked knocking that over. So we had to pay the same kind of attention to making sure that we didn't accidentally screw anything up, because if we did, it could potentially have catastrophic impact across the whole of our website. So we started to break things out. We wanted to make it that we had independent services so that we could work on have sort of different teams working on different systems and have them be able to go off in their own direction. And, you know, partly that was for the kind of technical reasons of not having to have those systems perform to the same extent, but also it was just around the kind of social issues you get when you get to a team of a certain size. So by this stage, we'd gone from when I joined having a team of sort of 10 or 12 up to kind of 30 or 40 regular developers. And so, you know, breaking that up into smaller teams helped to make things run more easily. And so we built a system which allowed us to stitch bits of content from other systems into that main website. So here's an example of one of those. So these are our crossword pages, and whilst the bits at the top and the bits which stick the ad in and do various other bits of navigation around the edges are constructed by that Java system I mentioned earlier, actually this crossword rendering and the little search for it there are built by a Python app running on App Engine. And this is then stitched, there's sort of a caching layer in between, a memcached layer, which gets the HTML and caches it and then stitches it into the page. It does a few nice things like serving stale on error. So if this system for the crosswords goes down, we can continue on with the last version we saw, which we've got in the cache. And this allowed us to scale out this kind of develop in terms of teams and mean that we weren't sort of bottlenecked up by a single system to do all of our development. And it also allowed us to do a bit of experimentation, so like using App Engine, like trying Python, and you know, we ended up doing most of our development in Scala, and that's predominantly what, in terms of the server side, what we do our development in these days. And having the freedom to try out new things on smaller systems meant that we had that freedom to experiment and find what worked for us as a team. However, there tends to be a however some point down the line for all of these things. And in this case, it was highlighted in particular back in 2010 when, in the middle of the first big WikiLeaks release, we had a Q&A with Julian Assange. So we didn't really have any good system for doing a Q&A, but what we did have was a commenting system. So we thought we'd use that. And these comments were pulled in the same way. And as you can see here, we've got 19 pages worth of comments by this point, because we'd kind of opened it up for questions early on, and there was a lot of interest, lots of people coming in and asking questions, but actually that's not what most people were interested in. Most people were interested in seeing what the answers were. And at the time, our comments weren't threaded, and so, and I don't think you could do the oldest, newest, first switch either at that point, so everybody just hit the flip switch to look at all of those comments. And our comment system wasn't the best performing at that point. And when lots and lots of people started trying to look at all thousands of the comments at the same time, the performance of it degraded badly. And unfortunately, it didn't break. If it had broken, then this would have, you know, we might not have got the answers visible, but the system would have carried on reasonably well. But it just went really, really slow. And because it wasn't the best performing system generally, the timeouts on it weren't terribly strict. And after a while, the system to actually integrate these components ground to a halt, and subsequently the entire website ground to a halt. So this kind of proved that our approach up to this point wasn't sustainable. This wasn't giving us that independence of allowing people to try and experiment with new things without risking the whole of the website, because we'd proved by unfortunate example that you could still bring down the whole of the website with one of these other services. So at this point, we sort of gradually moved over to a rough rule of thumb, which is that for any end user making a request to one of our systems, for one request, you only end up making a call to one back-end service. So what do I mean by that? Well, I'll show you a bit of an example. So this is a football match report here. And in this case, we've got the core bit of journalism written by our journalists, so the headline there, and there's some more text further down the page. But we also have some stats here on who scored what when, and some possession stats here. We integrate, these days, the way that we do that is to actually integrate those on the client. So when you load up this page, those, if you've got JavaScript turned off, you won't see that information. You'll still get the core information of the headline telling you the result and the match report, but you won't get that additional information about the scores and the possession stats as this. So we make a subsequent request back to an independent system which goes off potentially to talk to a third party to get that data, and then use JavaScript on the client side to integrate it back in. It's a bit more of a fiddle to do in some ways, but it means that if that system starts to degrade, then the worst that happens is we lose that information. We don't lose the core information about what is actually going on here. And similarly, we kind of have the inverse case here, where almost all the information on this page is actually coming from the third party. So, they know about what the goals for and against for all these teams are, and we go and fetch them from that, composite it, and render it out. But we also have specific pages for these teams where, if you click through on Chelsea, we'll show you all the recent news about Chelsea, for instance. And so we need to match up that information from the third party to our own internal representation of what Chelsea means. But in this case, we don't actually need to do that with something funky on the client side, because the number of football teams we care about is a finite, well-defined set. And so in that case, we can just make it so that we cache that information on the server which does the rendering of the football information for the third party, and make sure that's always in memory available to do this rendering, and then just refresh it on a periodic basis so that it's always available and we never have to actually block a user request to go and fetch that. So to give that a bit more of an illustration, I've got a little diagram here of the kind of way that we integrate these days. So one thing, when a user makes a request to TheGuardian these days, you're always going to go through Fastly. I don't know how many of you are familiar with Fastly. So they're a CDN or content delivery network. So they will cache content out near the users to reduce the round-trip latency. So we've got lots of readers we have an Australian office, we have lots of readers in Australia. the speed of light from there actually takes a reasonable amount of time to get to us and back. We want to be able to cache near them. There are a number of CDN providers, but what makes Fastly significantly different from the others is that they're running their sort of custom version of the Varnish cache, and Varnish has its own not particularly pleasant language called VCL, and with Fastly you can upload your own VCL to run on their edge servers. This gives us way more flexibility in terms of what we want to do with our cache than with other CDNs we've looked at, who generally you go and you say you want to do something different and they give you a consultancy price and tell you they'll get back to you in a few weeks later, and when they do, it generally doesn't work. So this has been fantastic for us in allowing us to spread out, to sort of keep a high degree of flexibility while still being able to cache on the edge and provide a single exposed domain to our users, so everything's on www.theguardian.com. So once we've got through there, that can work out whether it looks like a league table URL, in which case we'll go off and talk to our football app, which may in turn go off and talk to our sport data provider, or it might be an article, in which case we go off and talk to our content API, and that fetches it out of its data store, which happens to be Elasticsearch. But crucially, one of the things that we do here is actually, again, separate out the editing of that content from the serving of the content. So our tools are a separate set of information. They have their own sort of local data store, which happens to be Mongo, where we store the content which people are editing, and then on publish we have an asynchronous message going on and pull down into the content API. And what this means is, if and inevitably when we have problems with the tools, there's no way that they can impact the website, and vice versa. If we have the website being overloaded, their tools aren't affected by that. And this is kind of the key element that we try and adhere to, is minimizing the sort of surface area of any given failure. So that kind of wraps around in terms of where we've got to now in our thinking about how we actually want to scale. I mean, one other thing I should probably mention is that these days, all of this kind of infrastructure is on AWS. It's auto-scaling groups everywhere. We have triggers on various things like the latency of any of these services to scale up and provide more things. And as well as having that approach, one of the things that we found has been key to making it that these systems are actually more resilient has been making it so that there is a single team responsible for developing and supporting these services. So we used to be an organization which did have quite a, there was a point when effectively you had to say to an operations team, here is a release, these are the things in it, go and do the release, and then some point they would then come back to us and say, it's done, but we have no idea whether it actually worked because we haven't developed the feature, go away and have a look at it. We very much embrace the kind of DevOps ethos these days that it's a collaboration. The developers will push out their changes, they will monitor the systems that they're responsible for, and they will also potentially get a call if that system's failing. And that definitely has a strong incentivizing approach to actually make the systems more resilient to any issues. So, these are the kind of core principles that we have in terms of how we approach scaling. So, making it so that we can scale out of trouble. So, whenever possible, using a stateless system, and ideally where we do have stateful apps, using ones like Elasticsearch, where we can actually scale out the data source and provide the data store itself, and potentially, probably not as quickly, but still be able to respond to an unexpected peak in traffic or an unexpected source of load in a way that gives us more time to get to the bottom of the situation and not have to panic in the meantime. We try and keep this idea of optimizing for one particular scenario rather than trying to have one data representation to rule them all. So using Elasticsearch and the API on top of that for querying and Mongo for storing, for instance. And then having this idea that we have a number of discrete services, each with, and having a team responsible for each of those services, and having that team be able to deal with that independently, and having all of those teams think about the failure scenarios for any of the downstream systems that they depend on, and know how their system behaves when those downstream systems go and do go down. And then finally having this approach of trying to minimize the dependencies on any other downstream services from any of our services, so that when there is something that goes wrong, the surface area of that problem is smallest. Because, you know, everything fails. It's just that as you scale up and you have more things, things fail a lot more often. And if you're chaining together lots and lots of systems in a way where they can impact each other, then those failures start to spread across the entire system and really cause major damage. So yeah, we try and make it so that we're focused on always having the smallest failure possible whenever we do have a failure. And that's the kind of key heart of our approach to scaling. Okay, that's me about done. Thank you.